It is good to see 200 young boys and girls. It is, Bhubaneswar is not very cold yet, isn't it? It is warm. So let us get chilled, get cool, and let us go to a place where always, if you want to have ice creams, I find a lot of girls here, they must be liking very much ice creams and all that. So I go to a place where you will not get ready-made ice creams, you have to carry some syrups and sugar. You just put it, scoop it, and you have as much ice creams as you want. You can have breakfast in the ice cream, lunch with the ice creams, evening tiffin with the ice creams, as well as dinner with the ice creams. And not only that, in spite of taking so many ice creams, you will not catch cold, because there is no cold virus there. But you may get frostbite. That is a different issue. But you will not get, generally not get cough and cold, unless you are carrying it yourself. Anyway, so with this, my topic today is that before I start, that I welcome you also to this Inspire program, which is organized by, which is sanctioned by DST, Department of Science and Technology program, and KIT, especially the Department of Biotechnology, is one department or organizations which has done almost a record of approaching almost half a century of its installation. And I have been very beginning coming. It is for me a homecoming like thing. So I congratulate, or I welcome you all, and I also congratulate Dr. Mrityunjay Swar, Sanjukta and others who really make it successful, because it takes a lot of time and effort to really organize, bring 200 students to a place for 5 days and all that. There's a lot of behind the scene activities. So let us go to a journey to Antarctica, adventure and science. You see, science is also an adventure, because you are trying to understand the unknown, things which are not clearly known. So as you are trying to understand the unknown intellectually, so it is an adventure. Because you are not sure about the result, but there is an effort, and as there is a repeated effort, there is likely to be a success. Similarly, adventure, which is a physical adventure, going to Everest, climbing a mountain, going to North Pole, going to South Pole, these are distant places, unknown places, and this is what is called adventure, and there are plenty of other adventures also. So therefore, what has happened? So I wanted to fuse both these adventures, and I thought let me look at a place how does it look like. So now this is I have taken from the Nobel laureate Professor Venkatraman Ramakrishnan, who is an Indian but now an NRI. He is an American citizen, but he is now in England, working in England. He is a Nobel Prize in Chemistry, and he is now the president of the Fellow of the Royal Society this year. He had said something for which is maybe interesting for you today. Say that what has happened, he says scientists are like children because they continue to be fascinated by things. You see, a children is fascinated, anything new, he or she will ask a question, which may be sometimes very difficult to answer. He may say, why? A simple question, which is why moon is round? Or why moon is not round always? To explain it to like a child who will understand everything, is not. But he has a fascination. He sees moon, he or she sees moon, and sometimes he finds it is a full circle, sometimes it is not there, and sometimes it is only a path. So he or she may ask a question. So it is a childlike curiosity. Why does it happen? So the basic question is why. That is, so he says the best way to something to appreciate is like physics. He has said about physics. It could be chemistry, it could be mathematics, it could be biology, it could be earth sciences, any branches. He says, ask how physics helps to understand it. Similarly, as I told about the moon, well, what will happen? What we have to understand is that what exactly is the process going on, interplanetary process that is going on, that twice a month we see full moon, and then it goes on reducing in size and takes different types of shape. So what exactly has happened? Any phenomena you can take it. You can say why the seawater is blue in color, appears to be blue in color. Why the sky is blue. Take any natural phenomena. Why the leaves are green. Many of the leaves are green. Or why does it lose its greenery? It happens sometimes in various seasons. So what he says, take a natural phenomena and ask, how does it, try to understand, how does it really help to understand that phenomena. Advice for students, that is what exactly I have quoted this. You are now at the crossroad. Within a year or two, you will have to decide which side to go. And obviously there will be plenty of advice coming from, but it is ultimately, it is you who has to decide. And so you have to decide, but what he says is very important. Follow your interests. Well, you have developed certain interests, follow it up. And then he says, have confidence. Now you may think that I have followed this after some time, and my friend followed this, that appears to be rosy. That appears to be much more interesting and all that. No, don't waver. You have made your selection, have confidence in it. Everything is important and everything is needed by the society. So these fluctuations that you see, that's a part of the whole thing. So therefore, have confidence and don't feel insecure. We feel, so that, did I do a good thing by doing this? Will I be able to make a dent? So this is an insecurity. You have to do not feel insecure. So these are the most interesting statements that he has said. Follow your interest, have confidence, and do not feel insecure. So that is what I thought. I shall tell you what he said about it. Now what will happen? The question will come. Why Antarctica? I said you ask a question, why? Why sky is blue? Why leaves are green? And so on and so forth. Why during autumn the leaves fall down? And so many things. So the next question that should be asked to me, why Antarctica out of so many places in the planet Earth? What exactly has happened? There is a year called International Geophysical Year. It is done after a long time to really understand how things have developed. In 1956, it was an International Geophysical Year. At that time, they decided that Antarctica, which is covered entirely with snow, 98% of it is covered by snow, and only 2% is uncovered. And in that 2%, 1.5% is the top of the mountain ranges. And the rest 0.5% is when the glaciers recede. So they leave some permanently rock exposure, 0.5%. And they are called oases in the desert of ice. Antarctica is covered with ice. It can be referred as, it is a oasis of desert of ice. So in that, if you see some spots of rocky surface, we call that to be oasis. And that is 0.5% of the total area of Antarctica. Now the question comes, what is the size of Antarctica? Believe me, it is 4 times the size of India. And more than the size of India and China put together. So it's a huge big land mass. And 98% is covered with ice throughout the year. So therefore it was decided, and therefore as it is covered with ice, there is no vegetation, no life. But a higher form of life you may get in some lakes and all that, some microbes here and there, but higher forms of life because there is no food chain. Because for life to be there, then you will say, how is that we see in the Discovery Channel, Planet Earth and all that? What exactly we see? Penguins, we see seals and all that. They are not deep inside the interior. They are all in the coastal areas. Because their food is in the sea, Antarctica Sea. And there, that's why they will be available within 30-40 kilometers from the nearest sea. will not get very much deep inside because they will not be able to survive. Are you with me? Okay. So therefore, what has happened? They said this is which is not habited by mankind. It should be considered as a continent of science. And all countries should put together under certain conditions if they agree, and that was called Antarctica Treaty. And it was designed in 1959. Antarctica Treaty was signed by 1959. It was not a United Nations, it was a scientific treaty. Outside the United Nations, it was done 1959, and they said any 12 countries signed the treaty. It was America, those the Soviet Union, Japan, England, France, Argentina, and all that. There are some, Norway and South Africa, some such countries were there. They decided 12 countries, but they say anybody can join this, provided they accept the treaty officially, and also they can become a member of the club, Antarctica Club, if they put a laboratory which will be round the year operating. So that is the condition. First you have to, so India agreed to the treaty, but it took a lot of time for us to really reach there. So I shall tell you that story today. And then this is the coldest, windiest, driest continent of the world. It is very dry, humidity is very less. And coldest, and also along with cold, there is a lot of wind there. So it is not only the temperature, as there is a wind, the temperature feeling is much more, and it is called wind chill factor. In the month of, when if you go to any part in northern India and all that, when there is a cold, but if there is a wind coming from the Himalayas, so your feeling will shiver. That is the, not the temperature, it is the feeling of coldness that is called wind chill factor. So the temperature may be 15 degrees Celsius, but you have a feeling that quite like it is as cold as 5 degrees, because there is a wind along with the cold temperature. And this factor is called wind chill factor. So it is something like that. There is a warm, but there is a humidity, then it is a comfortable factor is much less. You will feel uncomfortable because of the humidity and temperature together. But if you go to North India, their humidity is less. So therefore, though temperature might be minus 40, 42, but your feeling will be not that uncomfortable as you go towards coast. And where the rainfall is, like northeast, eastern part of the country and all that. Now the question is, at the southern, today we are seeing Antarctica, an isolated land. But in geological past, it was not like that. There were several continents they were put together, like Antarctica, Australia, India, Africa, and South America. They are all put together 20 crore years back, 200 million years back, 10 million is 1 crore. So 200 million years back, they are all together. Gradually it broke up and it drifted apart. And India, from the southern hemisphere, came to the northern hemisphere. Others more or less remain in the southern hemisphere. So this joining together and that continent, bigger continent, is known as Gondwana land. It has been named after one of the very ancient tribes who live in the central India, Gond. It has been named after that, in honor of that community. Internationally, it has been accepted. Now, I shall show you now you see, this is the Gondwana land. Now this is what is the present position of this is India, this is Africa, this is South America, Antarctica, Australia. And we can see there is not much of continent in the southern hemisphere. It is more of ocean rather than land as you compare with the northern hemisphere. There you see many continents. So therefore what has happened? So now you can say this is the scale, 200 million years. Means MA is billion years. And I shall go back from the present day to the back and I shall go back to 200 million years. That means 20 crores of years. So watch it carefully, and you will see this map will be going on changing. And that is what exactly, you see. So we shall go into something like a time machine. From this, we are not going ahead, we are going backward, how things happen. Okay? So therefore, let us have a look at that. And you will see the details here. So how old it is, 7 million years, 8 million years. What does it mean? It is, you see, if you see that, you will see when there was a Himalaya, there was, you see, this is a ocean. So between India and the Tibet, there was an ocean. And sediments came there, and as India moved northward, the sediments wrapped up like a corrugated sheet, and it became Himalayas gradually. Still, India is going down below the Tibetan plate. Indian plate is moving down toward the independent plate. That's why the earthquake from time to time occurs. It is trying to balance. Now you can see that. Now you can see 57 million years. You see, this is the Deccan Trap. This is the Western India, Maharashtra, Gujarat, and all that. After 70 years, million years, it will disappear. You see? So India was here at this place. And still, these are also lavas, but they are much older lavas. And you can see this is Rajmahal. And this is much older than this, and this is about 125, 130. And these are called hot spots. So when the plate moves over the hot spots, the lava is accumulated. So you can see that there are some 10, 12 hot spots like that. Now you can see that after 100 million years, this was the scenario. And this is Madagascar. Madagascar, about 125, you see, this is what it is. So the Rajmahal Trap is very big. Now it is all under ocean. It goes up to Bangladesh, Shillong and all that Bangladesh, but it is below the sediments. But now you can see 125, it has disappeared. It is about 150, and these are still older. And now you can see that these are still older. Now you can see these three continents first separated out from these two continents. So there are two blocks, India, Antarctica and Australia, one block, and then this is Africa and Latin America. About 150 million years back, these two blocks separated from each other from the Gondwana land. And then gradually, Antarctica, India, Australia separated out, these two also separated out. So this is how things took place. And this is, as we see from the scientific studies, as we go back, as if we are going back in a time machine in crores of years. It is not in seconds or minutes and all that. It is, now you can see that this is Gondwana land. Planet Earth is still older, but I am showing it only for my purpose, the Gondwana land, and this is what exactly we are doing here. So you can see that this continent, you can see at 199, this continent is 200 million years back, and at that time it was all one land mass, and that is known as Gondwana land. Now, due to internal dynamic movement, it broke. These are the problems, these are the challenges. Why? How did it move? It was together. Why should it break up? Must be there are internal forces. What was the nature of the forces? Why everything did not move in a uniform way? You will see, I shall again come back to you, have seen that India has gone northward, this has gone westward, and this has gone eastward, and Antarctica has remained more or less in the same position. Why? All the questions have not yet been answered. They are waiting for you to answer many of these questions, if not all. You get me? So therefore you have a lot of challenges ahead of you, because we failed to explain it yet. So you will have to do the job. We are keeping some of the very challenging problems for you to say emphatically why it is happening. Now let me again go back and to see that now you have seen it. So go back and let us see what exactly has happened. From 200 million years back, now we shall come to the present time. And then you can see that. Wait, what happened? Now, it's moving. So this is what exactly, now we are going back from 200 million years to the present time. And then you can see that it is, you can see that first these three will break up from these two. It is like a jigsaw puzzle, you know. It is just like a jigsaw puzzle. And then a lot of work goes on. How it was, how things were, and all. You can see that, can you see that? These three are one, and still Madagascar is attached to India, western part. Then you see this. This is what happened. So Gondwana land became two mainly. And you can see that we are all neighbors once upon a time, geological time. Madagascar, India, Australia, and the eastern part of India was connected to this part of Australia. This entire part, this part was along with the eastern coast like Andhra Pradesh, Orissa and all that. This coastal region was connected to this part. And you can see that now you can see that 120, you can see that here will come. Rajmahal trap will appear gradually in this region. You see, it is going over a source, hotspot, which is regularly throws lava into this. So as the continent is moving, then as it has moved, this is only a small part is shown in the surface. It is all under the ocean. And if you see below the sediment, if it goes to Bangladesh and all that, this is huge big, you can see that. And you can see that, that now still this western part lava is not there. Bombay, Maharashtra, Gujarat and all that. But you should come when it is around 70 million, or 65, 70 million years, along with that come. And now you can see that it has moved. Can you see that Antarctica has not moved much further? But India is moving very fast. And Australia has moved, but not that much. But it has remained within the southern hemisphere. This has also remained in the southern hemisphere. This has slightly moved to the north, but it has remained mainly in the southern hemisphere. So, but you can see that. But India, now you can see that. And now there is a, between India is not adjoining to Tibet and all that. It is gradually moving, Indian plate is moving towards that. And you can see this is called Tethys Sea. And this sea sediments are going on over the millions and billions of years. Now as it is moving northward, these sediments will get crumpled like a corrugated sheet. And you see, this is now India is getting underneath the Tibetan plateau or European plate it is called, Eurasian plate. Now you can see, and this gives rise to Himalaya. And still now, it is going on every year, about 5-6 centimeters per year, it varies from place to place. So about 2 inches per year, India is going below the Tibetan plate. So we are losing every year without a war because of the natural processes, 2 inches every year over the entire length of more than 2,500 kilometers from Ladakh to Arunachal. It is a natural process we are going down. Now the question is, you should ask me a question, why India is going down? India could have gone up also. Why I am saying that India has gone down? And that's why. The question is that why should India go down and not India go up over the Tibet plateau? That is a question. Can anybody answer? Use simple physics. Try to answer, doesn't matter even if it is wrong. I would like you to. Which one will go down and which one will be up in the natural process of physics? Things which are lighter will go down and things which are heavier will, oh I'm so sorry, other way around. The things which are denser will go down, things which are heavier will go up. So whatever I say you did not accept, you should question it. Because the heavier things will go down, that is and the lighter things will be up. So Indian plate is heavy as compared to Tibetan plate. So that's why it is going down. And it is not the way a hot knife in a butter you put it, it is not that smooth. Because it will get resistance from the upper plate also. So there is a lot of, resistance is there, and ultimately the rock breaks. And when the rock breaks, the plate breaks, earthquake takes place. Yes, please.
Sir, why Indian plate is heavier than Tibetan?
No, that is what exactly has happened. That is a question. Why Indian plate? Because what exactly has happened, heavier density materials are more here, and here, the lighter density materials are more there. Then there are other things also, balancing. If there are two plates, they will have to balance it. That is called isostacy. You get me? So there is sufficient reason for the Indian plate to be heavier. Then also, these plates from the bottom, from time to time, what we call delaminate. That means it melts. So a lot of processes are taking place. Some processes we can think, some processes we are not yet very clear. So that is what exactly has happened. So therefore, what we do is now you can see this is how is the present scenario. So we have gradually gone, and now we are actually going below the Tibetan plateau, and as far as the Indian continent is concerned, it is from Ladakh to Arunachal. We are getting about 2,500 kilometers long, almost straight line or arc-like shape, gentle arc-like shape, which is going down. And that is the reason why Himalaya is so prone to earthquake. Not that other places are, there are Bhuj is prone to earthquake and all that. There are different regions, but that is where, because Indian plate is going down below the, what is that called, Tibetan plate or Eurasian plate, it is more scientific name. But as we are getting immediately north of Indian plate, Tibet, we call it Tibet plate. Okay? So that's why it is prone to earthquake. That area is prone to earthquake. And when an earthquake takes place, not every moment earthquake takes place. Because every plate has some sort of it can bear certain capacity to bear the stress. But a time comes when you cannot bear it anymore. Suppose you take a wooden plank, it will bend and all that, but after some time it will rupture. So that is what exactly things like that. Or even if you take a metal plate, it will, depending upon the properties, it will bend and all that, but if you still put force, it breaks from the weaker part. So similar things are happening. When ultimately it breaks and tries to adjust, then the earthquake takes place. And this place where it breaks can be anything from 10 meters to 100 kilometers, even more. But generally it is in the range of 10 to 40 kilometers. But there are places where earthquake has taken place, energy has released, I think greater than 40 kilometers, lesser than 10 kilometers. But this is the average. So this is what exactly has happened. So I call it as if, you see, there is a Nataraj. Nataraj is a very, very fine piece of sculpture. It is, the original is in the temple in Tamil Nadu called Chidambaram. So Nataraj is essentially Shiva's dancing posture. So Shiva has got two types of dancing mainly. One is Tandavas, which is destructing, another is Rasya, which is creating. So it is a creating and destructing processes going simultaneously. Here also there is as if there is a Nataraja inside the earth, which is creating and destructing. But that is a natural dynamic process that takes place. So earth is not, every time earthquake does not take place, we think earth is a very, very static place. No, lot of dynamic actions are taking place. And we get a feel of it, a light feel of it when a severe earthquake takes place. If an earthquake takes place in Sikkim, a severe earthquake, Bhubaneswar can rattle. Distractions will be much less, but Bhubaneswar can also rattle because that has got that much of distractive capacity. So this is what exactly oh sorry, I got to